Hi, in this video we're going to take a look at really large numbers, and we're going to take a look at moving them between standard form, scientific notation, and expanded form. Let's take a look. First, let's look at taking a number that's already in standard form and moving it into its scientific notation. Right here I have a number in standard form, 1,300,000. It's in standard form because it's written as you would normally see that number. To move it into scientific notation, when I'm first learning, I'm going to use a table like the one you see here, and that's going to help me out, and I'll show you how. What I first need to do is take my number and place one place after another, place it in my table. I'm going to put 0 because I have 0 in the ones column, in the ones column. I have 0 in the tens column, so I'm going to put a 0 there. 0 in the hundreds column, I'm going to place it there. Take a look for a second and see what I mean by hundreds column. This says 10 to the exponent 2. We know that 10 to the exponent 2 means 10 multiplied by 10, which we know equals 100. So really this is like a regular place value table, except all my tens places, all my different place value places are represented by 10 to a power rather than the number. So let's continue. I've placed 3 of my zeros there. I need to place the 0 in the thousands column, in the 10,000s column. Finally, I'm at the 100,000s column, 10 to the power of 5, which is 100,000, and that is a 300,000. And then finally, I have 1 million represented here. I don't need to go any further because I've represented my entire number. Now, what I need to do is I need to find a way to represent this number as a decimal to a certain power. So what I'm going to do is I'm going to actually pretend that I'm placing a decimal right here, okay, and I'm going to rewrite this number as 1.3. I don't have to go any further because all the rest of my digits are zeros. So it's 1.3 times 10, and then how do I decide what power it is? Well, I'm going to look at where was the power, where was the exponent for my first number. It was 10 to the exponent 6, so that's going to be what I multiply by. 10 to the exponent 6, 1.3 times 10 to the exponent 6. Just to sort of help clarify what this all means, it means essentially that to get my original number, I would have to move the decimal place 1, 2, 3, 4, 5, 6 places. Okay, that sort of explains why it's 10 to the exponent 6, aside from the fact that that's where it fits within the table. So this would be my scientific notation for this number. Now let's look at how to take a number and move it from standard form to expanded form. Now, just a quick reminder, when I'm working with expanded form, I'm taking my number that's in standard form and I'm breaking it into pieces according to its place value. So for a simple example, if I have the number 2,231, then in expanded form, I'm actually just going to take note of where each of my digits in this number is. So what I'll end up saying is that is equal to 2,000 plus 200 plus 30 plus 1. So what I'm doing is I'm drawing basically a connection between each of the numbers as they appear in place value, and I'm breaking them into pieces. So expanded form with these large numbers works roughly the same way. Let's look at the number that I've placed in the place value chart like I did before. Instead of saying 1 million plus 300,000, what I'm actually going to do is I'm going to use these exponents to those powers. So instead of saying 1 million, I'm going to write 1 times 10 to the power of 6 plus 3 times 10 to the power of 5. I don't need to do anything for any of the other columns because all the columns are filled in with a 0, meaning I don't have any values in there. So this would be my expanded form for this extra large number. 1 times 10 to the 6, because that's what's in my column of 10 to the power of 6, plus 3 times 10 to the 5th power, because that's what's in that column. And these are all 0, so I don't have to represent them at all. This is my final representation of expanded form. Now let's look at how we'll take a number that's already in scientific notation and move it to both standard form and expanded form. Once again, I'm going to use this table, this place value table, to help me. Now in this case, it might seem a little bit trickier to place my number. The number I'm looking at is 1.235 multiplied by 10 to the power of 8, but it's actually relatively easy to place it. All I'm going to do is start backwards, so start from the higher numbers rather than my ones column, and I'm going to place the first number, this one right here, in whatever place I'm multiplying by. So I'm multiplying by 10 to the power of 8, so that's where the 1 is going to be placed. Then I just have to place the numbers in sequence. And when I get to the end of that I know I have no other numbers, I'm going to replace the rest with zeros. So if we take a look, I've actually basically placed my number in standard form in the place value chart. It's a large number, so let's take a look at what that looks like. So my standard form is going to equal, let's see here, I want to make sure I do the place value right. 1, 2, 3, 5, 0, 0, 0, 0, 0. So it's basically 123,500,000. That's the number in standard form. Once again, I'm just keeping the numbers 123,500,000 right there. There's my standard number. Once I've got my number in the place value table, it's actually relatively easy for me to do expanded form as well. So just for short form, for EXP, expanded form, and I'm just going to pay attention to what column each of my numbers are in. So expanded form for this equals 1 times 10 to the power of 8 plus 2 times 10 to the power of 7 plus 3 times 10 to the power of 6 plus 5 times 10 to the power of 5. And I don't need to add any more because again the value is always 0. So as you can see, each of my little multiplication statements here agrees with one of the columns in my table where there's a value, a numerical value that's not 0. And that is my expanded form for this number. The final thing we'll look at is taking a number that's already in expanded form and placing it in both standard form and its scientific notation. So right here I have a number that's in expanded form. I have to really pay attention to the sort of little clusters that partner together, the multiplication equations and the separate pieces, because that's really my hint as to where these things go in the place value chart. I'm going to look at each one in turn and figure out where it goes from there. Here I have 1 times 10 to the power of 3. That means I'm going to go to the column 10 to the power of 3, and in there I'm going to place that 1. That gives me a pretty good hint about where to go, but let's take a look at the next ones. Then I have 2 times 10 to the power of 2, so I look at 10 to the power of 2, I'm going to place a 2 in there. Then I have 3 times 10. Now notice my chart says 3 times 10 to the power of 1. This is a place where students sometimes get confused. I have to remember that anytime I see just 10, it is really the same as saying 10 to the power of 1, because that just means one set of 10. 10, right? So it's interchangeable. 10 is equal to 10 to the power of 1. I have to keep that in mind. So there I need to place a 3, and then the final column is not to the power of any 10, it's just my ones column, so I'm going to place that 1 in that column right there. So if I'm looking at standard form, I've got a pretty basic number in front of me. So there's my standard form, and that equals 1,231. I know that because just looking at my place value, I kind of recognize where these places are, the ones column, tens column, the hundreds column, and thousands column. Or if I'm feeling at all confused, I can do the actual equation 10 times 10 times 10, for example, right here, which equals 1,000. So I know that that's my thousands column. Okay? Now for scientific notation, it's also more or less done for me. So scientific notation, just a little short form there. And that's going to mean that I have to again write a decimal. So I'm going to write this number as a decimal, starting with 1.231. And because my number starts, again, right here at 10 to the power of 3, that's what I'm going to multiply, times 10 to the power of 3. I can check and make sure this is correct by basically checking with decimal places. If I move 1, 2, 3 decimal places, do I get my original standard form number? I do. Okay, this number becomes 1,231. That lets me know that my exponent 3 matches up with that, and it makes sense. Okay, so there we've looked at how to find the move between expanded form, standard form, and scientific notation. I think the key to remember is that for each of them, what was so helpful to me was this place value chart right here. Without this, it would be extremely difficult to do these equations, especially to do these transformations, I should say, especially when I'm just starting out. I really want to get in the habit of using these. It's a quick thing to draw into your book, 11 column by 2, and it's really easy and sort of helpful for me in when I'm solving these. So get in the habit of drawing this chart every single time until you feel like you've got it by memory.